For thousands of years, the moon has dominated our view. The naked eye makes observations. It sees dark and bright patches on its surface. Man's imagination leads on to pictures, faces, and stories about these patterns. But why are they there? It was once thought that the dark patches were oceans and the white patches were land. Then, about 400 years ago, the invention of the telescope gave an improved, closer look of the moon. This fantastic invention was put to good use by European scientists. It was believed that an Italian astronomer named Galileo was the first to map the lunar surface. However, later discoveries had revealed that sketches of the moon's surface was made a year earlier in 1608 by the English scientist Thomas Harriot. Unfortunately, his sketches lacked a level of detail. Galileo had constructed a more powerful telescope and was able to resolve more detail of the surface features. This resolution helped him to notice that the dark regions were smooth and the bright regions were rough. A junkyard of craters.
How are these craters formed? How?
Ever since the later half of the 20th century, it has been a struggle to understand the origin of these craters. In fact, most observers believed that the lunar craters were the remains of volcanoes.
They were wrong.
We know now that this isn't true, but back in the 1900s to 1950s, there were three objections to the impact hypothesis. 1. If the craters were due to impacts, where are all the impacts on Earth? Answer. We know today of some 200 impact craters on Earth, but there must have been many more that have eroded due to things that occur on Earth, like plate tectonics. This geological process was not known at the time. 2. Out of the somewhat 200 impact craters on Earth, none have central peaks, like some on the Moon. Answer. The craters that still remain on Earth are too small to have formed central peaks. This process of forming peaks only happens to the biggest craters on the Moon, at least 15 kilometers or larger. 3. The most puzzling objection of them all was, why are all the impacts circular? It is unlikely for all meteorites to fall at 90 degrees to the Moon's surface. Many collide at an angle, so why are there a lack of elliptical craters? With the help of mathematical analysis by New Zealander A.C. Gifford, an answer arose. Due to great speed, some called hypervelocities, impacting meteorites travelling kilometers per second would instantaneously release a tremendous amount of energy in a violent point source explosion. This explosion would produce a circular crater at least 10 times larger than the hole from the projectile. Okay, time for an overcap, so listen up. What physics governs the way craters form? During contact, because the meteorite is travelling so fast, it pushes the solid surface of the Moon down and sideways, sending shock waves in those directions, a bit like sound waves, but more massive. The shock waves creates intense pressure on the Moon's surface, which results in the rock from the meteorite and the Moon to melt and vaporize. During the second stage, the shock wave that passes deep into the Moon's surface is bounced back and decompressed. This results with curtains of material ejecting out and raining down on the surface. In a short time, an explosion causes a hole 10 times larger than before. This explosion turns up a slab of rock, forming the rim. For larger and more energetic impacts, complex craters form. It is believed that the rock debris that have been crushed in the compression stage acts and moves like a liquid. This is due to a strong impact pressure wave. The fluidized region allows the walls to flow and collapse inwards towards the center of the crater. The material converges in the middle and pushes up the rocks that become the central peak. The fastest geological process that we know of. If you were thinking that not much can be told about the Moon's history of impacts and craters, you are wrong, as it is possible to link the crater's history to the Great Bombardment, a rain of asteroids caused by the rapid formation of Jupiter disturbing the circular orbits of the asteroids. The effect of Jupiter was to send a large number of asteroids and fragments into the inner solar system. It was these that created all the inner planets. The obvious evidence remains on our Moon.
So, the question now is, are we still in the asteroids firing line?